What if 10 homemade drones could rewrite the physics of modern warfare? On a quiet night over Ukraine, a small team of engineers and soldiers watched their screens glow inside a dark hangar. No radio chatter, no ceremony, just the hum of generators and the low pulse of engines spinning up one by one. Each drone no larger than a dining room table, each carrying a warhead barely heavier than a bowling ball. Their destination, a Russian military factory, so secret it wasn't supposed to exist, nearly 400 miles away. The odds were absurd. Russia's air defenses, layered radars, electronic fences, and fighter patrols had stopped almost everything that moved. But these drones were different. They would fly so low they could brush the tops of power lines, their shadows racing across frozen fields. Their guidance systems were stripped down to the essentials: gyros, cameras, a heartbeat of code. At 2:17 a.m., 10 silhouettes lifted off into the dark. For a moment they looked fragile, like fireflies drifting into a storm. Yet within those fragile wings lived a kind of defiance, a belief that precision and sacrifice could outsmart power. This is the story of how they crossed 625 miles of hostile sky and changed the math of war forever. It began with silence, the kind that hums just before history bends. 10 Ukrainian drones built in workshops smaller than a high school gym rose one by one into the night. Their wings trembled against the cold air propellers, spinning at 7,000 revolutions per minute, carving invisible scars through the darkness. There were no formation lights, no radar transponders, only coordinates loaded into memory and a faith in math. They climbed to barely 200 feet, then leveled off, skimming over farmland and rivers so low their downwash rippled through morning fog. From above, they looked like drifting shadows. From below, they were ghosts. The plan was brutally simple: stay under the radar horizon, ride the curvature of the Earth, and never break radio silence. For the next hour, they threaded through power line corridors, timing each crossing between pylons like heartbeats. The navigation computers whispered corrections, comparing gyro drift to inertial change, fighting tiny errors that over hundreds of miles could become fatal. Every vibration, every gust of crosswind meant recalculating survival. In control bunkers hundreds of miles away, operators watched only dots on a black screen, each pulse of telemetry a heartbeat of metal and code. When the first drone slipped past the border radar at 2:43 a.m., someone exhaled for the first time in 20 minutes. The impossible had already begun. They were flying into the densest air defense network on Earth, multiple layers of radars, jammers, and missiles designed to crush anything larger than a seagull. Yet these 10 machines kept moving, guided by precision and something that no algorithm could measure: defiance. No one in that bunker said it aloud, but everyone knew the truth. If even one drone reached its target, it would prove a single terrifying idea: that in modern war, courage could be programmed, and small could still defeat impossible. At 3:09 a.m., a Russian Su-35 fighter cut through the upper troposphere 31,000 feet up, cruising at Mach 0.9. Its radar, a masterpiece of silicon and paranoia, swept the night in 90-degree arcs. On a good day, it could spot a fighter jet 150 miles away. Tonight, it saw something else. 10 tiny echoes, faint, irregular, appearing and vanishing like static. The pilot frowned. His instrument said maybe birds, but his instincts said no. The pulse rhythm was too precise: 7,400 revolutions per minute. Propellers, drones. He rolled, slightly banking to line up the cluster thumb, hovering over the weapons release. 2 R-77 air-to-air missiles armed with radar seekers waited under the wings, each one worth more than a suburban house. Range 11 miles. Time to intercept 13 seconds. Down below, the drones heard at first the distinct Doppler howl of an afterburner lighting up. They didn't have pilots or fear or adrenaline, but their algorithms did the next best thing. They cut power. Instantly, 10 clean radar returns collapsed into nothing. Here's the physics that saved them. At 200 feet above the ground, radar waves bounce off the Earth, creating a mirror image beneath the target. The missile's computer must choose which reflection is real. One is slightly stronger, one slightly delayed. When the signal fades, the logic tree breaks. The missile chooses wrong. The first warhead hit an empty field 2 miles west of the formation, throwing soil 100 feet into the air. The pilot cursed. He'd just watched a $1 million weapon chase a shadow. Then one contact brightened Drone 3 climbing to 1,500 feet, full-power deliberate sacrifice. The missile founded and detonated mid-air, a brief star over the plains. In that flash, 8 other drones slipped past undetected. For the Su-35 pilot, it was just another blip lost in ground clutter. For the operators watching from Ukraine, it was proof that equations, not wings, could outfly a fighter jet. By 4:22 a.m., the surviving 8 drones were deep inside Russian airspace, 280 miles from launch, gliding steady at just over 600 feet. To the naked eye, they were nothing specks against a violet horizon. To the sensors below, they were ghosts moving through static. Then, without warning, every GPS reading blinked out. Not degraded, deleted. The screens inside Ukraine went black. The satellites still orbited, but their whispers had been drowned in a storm of man-made thunder. On the ground, 4 armored vehicles had deployed a jamming grid, Borisov-Glebsk 2, an electronic war machine built to erase space itself. Each antenna blasted hundreds of watts of interference across the radio spectrum. Compared to the weak 0.00025 watt GPS signal, it was like shouting into a hurricane. The jammers didn't just confuse the drones, they blinded them. Inside each airframe, gyroscopes spun, trying to hold a line. But with every second, the inertial drift grew 1/10 of a degree here, another there. Over 100 miles that meant missing the target by more than a quarter mile. The math was turning fatal. The lead drone's processor ran the numbers. Success probability dropping below mission threshold. Decision transmit a 2-second burst for synchronization. Just 2 seconds. 8 miles away, a Moskva-1 electronic intelligence array heard it, 3 antenna towers spaced in a perfect triangle synchronized by atomic clocks. The signal reached one tower a microsecond earlier than the next. That was enough. Target fixed. In a Russian bunker, a commander gave a nod. 6 missiles launched. The Ukrainian operators saw it in silence, one drone's trace, climbing, broadcasting, continuously dragging the missiles away like a beacon of light. Then the trace vanished. Static filled the screens. 8 drones still alive, 1 gone. A tiny act of machine sacrifice bought them a corridor through the storm. By 5:16 a.m., the 8 surviving drones crossed into Penza Oblast. Their wings shimmered in pre-dawn light engines throttled down to the bare minimum. No radar, no radio, no signals of any kind, only the steady pulse of propellers slicing through the cold air. They believed they were invisible. They weren't. Hidden in the forest below was something new. Not radar, not infrared. An acoustic reconnaissance network called Penicillin 8 microphones arranged in a perfect geometric pattern spread across half a mile of quiet Russian countryside. Each sensor could hear a helicopter 7 miles away, a drone at 12. Sound moves at roughly 125 feet per second, and the difference between a hit and a miss could be measured in microseconds. When a drone's whine reached the first sensor, it was already a fraction of a heartbeat behind on the second and a whisper behind on the third. 3 delays form 2 curves. 2 curves intersect in one point the drone's position. Simple math, deadly precision. Penicillin had been trained on captured Ukrainian drones before. It knew the exact harmonic pattern of those small Chinese-made engines, the pitch, the overtones, the 7400 RPM signature that sounded like a razor cutting air. When the pattern matched, the system didn't hesitate. Coordinates flashed red. A nearby Tor M2 air defense battery launched its first missile, blindly trusting only the numbers. Mach 2.5 in 3 seconds. Silence. No radar pings, no guidance beams, just pure data. The drones never saw it coming. The first exploded mid-air, shredded by 3,000 tungsten cubes. The survivors panicked, their flight computers flooding with random throttle commands, 50% full power half again, changing the frequency pattern so fast that Penicillin lost its lock. 2 missiles detonated too early, fooled by Doppler chaos. 3 drones dove under 20 feet, skimming wheat stubble and irrigation ditches. The missiles could no longer tell where the ground ended and the air began. When the dust settled, 6 drones remained battered, fast, and angry. They had outflown radar. They had outsmarted math. Now they raced toward destiny and toward the final trap. By 6:04 a.m., the 6 remaining drones were less than 30 miles from their target. The sun was rising, now spilling gold across the fields of Penza. The mission clock ticked into its 6th hour. Fuel was tight nerves tighter if machines could feel such things. Then, like a miracle, GPS came back. But miracles in war are rarely real. Each drone's navigation screen lit up again, crisp signals, strong connections, perfect coordinates. Too perfect. The numbers made sense to the satellites, but not to the sky around them. Visual sensors showed the factory's smokestack straight ahead. GPS said they were 3 miles south and climbing 800 feet per minute. Something was lying. They had entered the radius of Pole 21 Russia's most advanced GPS spoofing field. 4 antennas ringed the facility, each pushing 500 watts of counterfeit satellite data cleaner, sharper and more believable than the real thing 20,000 miles above. The system didn't block signals, it replaced them. Inside each drone's processor, logic began to unravel. The flight computer trusted GPS above all else, its word was law, but now every instrument disagreed. Compass said north, inertial system said east. GPS screamed turn right, climb, accelerate. Autopilots began to oscillate violently left, right, up, down, fighting a war against themselves. Wings flexed, motors howled. Flight paths crossed like tangled threads of chaos. One drone, by sheer probability or divine coincidence, ignored the false data. Its visual feed locked onto the correct shape, the distinct roofline of the Poliana D4M1 command facility. The processor overrode the confusion-held heading and dove. At 16:20 local time, the first impact hit like a punctuation mark written in fire. The shaped charge sliced through 40 millimeters of steel-rupturing solvent tanks beneath. Trichloroethylene, acetone, hydrogen peroxide. Mixed together, they didn't burn, they detonated. The explosion moved faster than sound, tearing the sky into a dome of flame. For 1 second, everything was light. Then came the shockwave rolling across the plain like the heartbeat of a new kind of war. The first detonation was only the beginning. Within seconds, the Poliana complex, 40 acres of concrete, steel, and glass, turned into a living storm. Pressure waves raced down assembly corridors, ripping doors from hinges and scattering workers through clouds of dust and flame. At 6:22 a.m., the second drone arrived. Guided by the smoke column, it locked onto the heat bloom of the explosion. Its onboard optics identified the same roofline now torn open like a wound. The drone adjusted dove at a 45-degree angle and struck the transformer yard. The blast unleashed a pulse of electromagnetic energy strong enough to fry every circuit within a half-mile radius. Monitors blinked out. Radar feeds froze. The third, fourth, and fifth drones came in almost simultaneously, each following the beacon of fire like moths drawn to light. One slammed into the warehouse district where 6 months of lithium-ion batteries were stored. The ignition temperature was instant 12,000 degrees, enough to melt aluminum and steel into rivers of light. Another struck the administrative wing, collapsing the roof inward. By the time the sixth drone arrived, there was almost nothing left to hit. It circled once, recording what the others had done, then tilted its nose and descended into the only building still standing. The explosion that followed folded the structure inward as if gravity itself had taken sides. From above, the destruction looked surgical, not chaos, but precision. 6 points of impact forming a perfect vector across the map. In Kiev, the operators watched the telemetry fade one by one until the last heartbeat of data turned to static. No cheers, no applause, just silence. The Poliana D4M1 facility was gone. Without it, Russia's S-300 and S-400 missile networks would lose their coordination reaction. Times tripled, intercept rates halved. The heart of an air defense empire had just been cut out by machines that weren't supposed to survive. And as dawn broke over Penza, the fires of precision burned brighter than victory itself. In the end, this story isn't just about drones or warfare. It's about what happens when intelligence, courage, and belief intersect even inside something made of wires and code. These machines weren't heroes, but they carried the choices of the people who built them. Engineers, soldiers, dreamers who refused to accept limits. In a world that celebrates power, this mission reminds us that precision often matters more than force. 10 small machines challenge the most complex defense network on Earth, not through strength, but through understanding physics, timing, and sacrifice. That lesson applies far beyond battlefields. In life, precision means knowing what matters, cutting through noise, and trusting quiet discipline over noise and pride. Sometimes victory doesn't roar. It whispers through the patience to calculate, the humility to adapt, and the courage to try one more time when logic says, stop. Progress in science, business, or personal life isn't about winning every fight. It's about daring to refine, improve, and persist until the impossible starts to bend. Technology may evolve, but purpose is still human. And whether it's in a lab, a cockpit, or an ordinary day, the rule remains the same. Don't aim to be louder, aim to be sharper, because in every field, precision is still the new mercy.